Hi everybody, and today we're going to be talking about adding and subtracting real numbers. We're going to talk specifically about conceptually how we're able to do that. And so we're going to introduce the number line in order for us to be able to go ahead and truly understand how to do this. I do have our learning objectives there. We're going to talk about negatives and opposites. We're also going to simplify expressions with absolute value, and we're going to add and subtract integers. And when we talk about integers, we're talking about whole numbers in both the positive and the negative direction, including 0. Okay, so we're going to just go ahead and jump right in. We are going to use, okay, I have purple, a little bit thicker, perfect. So we're going to start with an intro, and we're going to pretend we're walking on a number line. And when we're saying a number line, it's just literally a line where it measures from 0 going to the right positive numbers, 0 going to the left negative numbers. So I'm starting at 3. So here's my little guy. I'm starting at 3. And it says, then walk 6 units in the opposite direction. So I'm going in the direction the guy is going, and I'm starting at 3. So I'm going to start moving to the left 1, 2, 3, 4, 5, 6 units. So I moved 6 units to the left. Okay, so I'm ending up here at -3. And then I'm turning around essentially, and I am going to be going in the right direction 2 units. So 1, 2. So I moved in this direction 2 units, and I'm ending up at -1. So basically what we just did is we added and subtracted some numbers. So I started at 3 and I went 6 units in the left direction, and the way we determine left direction is negative. So I did 3 plus a -6. Okay, I really subtracted. I went 6 units in the opposite direction. Okay, and then what I did is I said, all right, and now I turned around and I went 2 units to the right direction, which we denote as a plus. So that's plus 2 units. And when we added all of that together, it gave us a -1. Okay, so again, I talked briefly about the number line. It's just literally a line where 0 is kind of the big number, and everything going to the right, okay, is positive. Everything going to the left is negative. And so what is important to know is the more to the right you are, the larger the numbers are, and the more to the left you are, the smaller the numbers are. Okay, so that's just a little bit of a heads up. Now let's talk about these examples. And I gave us a number line there so that we can really focus on where we are in the number line, and then we're going to talk about kind of grouping these together. So I always am going to start with that first number. So that's going to be my start position in all of my examples. So for example 1, I have -5 as my first number, so that is where I'm starting. And then I have plus, which is just telling us add -3. And so the negative tells us, or the negative or the positive tells us in which direction we're going. So because I'm adding onto my walk, but I'm going in the negative direction, okay, I'm going to go to the left. That's what that negative direction is telling me. If it just had, like, for example 2, I'm starting at 4, but I have plus 6, which means the 6 is positive. So I'd be going in the positive direction in that case. So I'd be going to the right. And so I always like to kind of write positives and negatives on all of my number lines, because that tells me what direction I'm going. So because I'm going, because it's -3, I'm going in the left direction, which means I'm going in the negative direction. So I'm starting at -5, I'm going 1, 2, 3 in the negative direction, and I end up at -8. So that is going to be my number there. Now, for example 2, I'm starting in the positive 4, and then I'm adding a 6. And since the 6 is positive, I'm going to go in the positive direction. So I'm going to do 1, 2, 3, 4, 5, 6. And I end up at positive 10. And so that would be my answer for this example. Now, example 3, I'm starting at negative 4. And I'm adding a positive 12. So I'm going in the right direction, 12 units. So I'm going to count 1, 2, 3, 4, 5, 6, 7, and 8. So, 8, not 12. 8, 9, 10, 11, 12. There we go. Okay, so I ended up at a positive 8. Now, for my last example, I'm starting at positive 6, and then I'm doing plus a negative 7. So this time I'm going in the negative direction, 7 units. So 1, 2, 3, 4, 5, 6, 7, and I end up at negative 1. So that's my answer. Now, I'm going to kind of group my examples, and I'm going to just go ahead and do it. Kind of like this thicker one, and I'll do this green. Okay, so I'm going to group these two together, and I'm going to group these two together. And there's a reason for why I'm doing that, because I noticed for examples 1 and 2, I noticed that both of my examples have the same sign. Okay, so I'm going to have very specific rules for those. And then for 3 and 4, I have different signs. And so I'm going to have different rules for those. So different signs. Okay. So if I notice, for example, 1 and 2, my first set of examples, both numbers are negative, and I end up with a negative number. And for my example 2, both numbers are positive, and I end up with a positive number. So when the signs are the same, when both numbers are either positive or negative, then we're going to add the numbers together and keep the signs the same. Okay, so 1, negative 5, negative 3, we add the 5 and 3 together, which is 8, and since both numbers are negative, the 8's also negative. Okay, now for example 3 and 4, the signs are different, and this is an important one to remember. So when one number is positive and the other number is negative, that would mean different signs. Then you're going to find the difference and keep the sign of the larger number. So what does that look like? So for number 3, the difference between 4 and 12 is 8. Okay, and then I take a look at which one's my larger number, 4 or 12. 12's my larger number. And since 12 is my larger number and it is positive, then the answer is also positive. Okay, so for number 4, if I take a look at the difference between 6 and 7, it's 1. Okay, and then I take a look at the larger number. Well, the larger number is 7, and since 7 is negative, then that means to say the answer is also negative. Okay, now we have a few more things to cover, so I'm kind of zoom through a couple of these. So another example would be when the numbers are the same, but one's positive and one's negative. And your answer for that is always going to be 0 because you're traveling the same distance all the time. Now, those are what we call opposites. Or we could also call them additive inverses. And the reason is because when you add the numbers together, they're always going to equal 0. Okay, so that's kind of an example of an additive inverse. And then you could have any number. I chose 7 and -7. It could be -3 and +3, or 24 and -24. All of those are additive inverses as long as the numbers are the same. One's positive, one's negative. Now, let's talk about subtracting real numbers. So subtracting a number is the same as adding its negative. So if we take a look at my first example over here, 2 minus 3, I could rewrite that as 2 plus a -3. Okay, and if we were to take a look at it as an addition problem, then we notice that the 2 is positive, 3 is negative, and what we would just do is we would take the difference, which is 1, and we keep the sign of the larger number, which is -3. So my answer is going to be -1. Now for my second example here, okay, I have -6 minus 7. So if I were to rewrite that as an addition problem, my first number stays the same. I change the negative to a positive, and I keep that negative with the number, so -7. And then they're the same signs in this case. They're both negative, so my answer is going to be negative, and then I would just add them together. So 6 plus 7 is 13, and that would be my answer, -13. So basically we can write any subtraction problem as an addition problem. Okay, now the only special note here is if you have two negatives together. Basically what that means is take the opposite of the negative, which means what's the opposite of a negative? Well, what's the opposite of negative? Positive. So that's why we would end up with a +3 in this particular case. Okay. Now, lastly, we're going to go ahead and talk about absolute value. We're not actually going to do this example because we haven't talked about orders of operations, which you would need for that. However, we are going to talk about what absolute value means, and conceptually, meaning to say, thinking about the big picture. Absolute value is measuring the distance a number is from 0, and distance really doesn't have a direction. You're just saying how much did you actually travel, not in what direction did you travel, which would be positive or negative. You're just saying what is the actual distance, okay? How far is it from 0? And so you denote absolute value as the absolute value bars, and since we're talking about distance, and distance is always positive, you're always going to end up with a positive number because distance is positive. So for example, if I have -5, okay, I'm starting at -5, and I want to know how far away am I from 0. So I would count 1, 2, 3, 4, 5. Well, I am 5 units away from 0, which is why my answer is 5. And then if I were to go ahead and do it in the opposite direction, and I'll change my color here. If I were to start at +5, and I still want to know how far away am I from 0, I'd count 1, 2, 3, 4, 5. So again, my distance is 5. Okay, and it could be the same for the absolute value of -12. Well, that's just going to be +12. Okay, or you could say, what is the distance, the absolute value of 6? Well, that's just +6. So it really kind of doesn't matter. Your answer is always going to be positive, and it's always going to be the number itself. It just removes the negative if you have one. Okay, so that's what we are covering today. Please tune in to see the next video, which is going to be multiplying and dividing real numbers.